Alright, just a couple problems left. Find a formula for this elasticity. We had two formulas for elasticity. One was negative percent change in Q over the percent change in P. That's the one we talked about last time. The other one is it's negative dQ dP times P over Q. And this is the one we're using this time, because we have a formula for Q in terms of P. So Q is 10 minus 11P, so dQ dP is negative 11. So elasticity is negative 11 times P is the variable P, Q is the function 10 minus 11P. So this is 11P over 10 minus 11P. Okay. What is the elasticity at a price of 250? What's E of 250? Oh, I think this problem was broken. Oh, yeah. Sorry, this is a price at which demand goes negative. 10 minus 11 times 250 is a negative number, so the problem doesn't make any sense with 250. Let's change the problem so it said 25 cents. Sorry about that. What's the elasticity of 25 cents? It's 11 times 0.25 divided by 11 divided by 10 minus 11 times 0.25. What is that? .379. There's our elasticity. Is demand elastic or inelastic? This is less than 1, so demand is inelastic at that price. Should we increase or decrease the price to increase our revenue? Okay, this I can never keep straight in my head. Elasticity, when you're inelastic, you got a small fraction. The top is small, the bottom is big. A big change in price has a small change in sales. So if I jack up the price, they don't care enough about it to make it not worth it. Yeah, we should increase the price to increase revenue. Cool. There's our elasticity one. Last problem. I didn't mention this when I posted the exam. If you want to pause the video and try the problem on your own, go for it. It's 2400. I guess I don't need to explain to you that you can pause the video. I want to build a 2,400 square foot rectangular pasture. It'll be made of fencing with an extra wall in the interior, like this picture. What dimensions minimize the amount of fencing we needed? There's two dimensions here. We got a length, we got a width. The total amount of fencing will be these 3 walls. So fencing needed will be W plus W plus W plus these 2 walls, plus L is 3W plus 2L. I'll call that F for fencing. I want to maximize this, but I can't maximize this because this has too many variables. What extra constraint do I use to get rid of these variables? Well, it's going to be 2,400 square feet total. So that's area is length times width needs to be 2,400. I need to solve this for one of these variables. I will solve it for I'll solve it for L to get rid of the L, because writing cursive L's in math is annoying. Length is 2,400 over W, so my formula for fencing becomes 3W plus 2, 2,400 over W. So that's 3W plus 4,800 over W. That's 3W plus 4800 w to the negative 1. Now it's a function of one variable. I need to minimize this, and I need to show how I know that it's a minimum. Some problems will say that, some problems won't. Let's take the derivative. That's 3. Oh, I guess I should specify the domain. Anything positive works, right? If the width goes down to 0, then it's not 2400. But the width can go as big as you want with a tiny length, and it'll still make sense. Yeah, any positive number makes sense. What's the derivative of this? It's 3 minus 4800 w to the negative 2. It's not too hard to take a second derivative and get negative positive 9600 w to the negative 3. That's negative. If double prime is negative, so any critical point is the global negative is concave down global max. Wait, max? Max? Have I screwed this up? No. The part I screwed up is where I said it's negative. That's the plus sign out front. That's positive. So it's positive, so any critical point is a global min. Okay. What is that min? It's the critical point, if there is one. 3 minus 4800 w to the negative 2. Do you ever equal 0? That's when 3 equals 4800 w to the negative 2. That means 4800 over w squared. Let's multiply both sides by w squared. Let's divide both sides by 3. I get w squared. It's 4800 over 3. 4800 divided by 3 is 1600. Hey, that was nice of me. I rigged this one up to have a square root. The square root of that is w is 40. The minimum fencing is when the width is 40. What are the dimensions? So I need the length. Well, the length is 2400 over w. That's 2400 over 40. That's 60. Dimensions are minimized, or fencing is minimized by a 40-foot by 60-foot pasture. That's the best ratio to use. That's the practice exam. Make sure you check online Friday. Hey, if you're watching this video, why don't you send me a text to let me know, because I haven't heard anything from any student in a while. Nice to know someone's out there.